Now we try to explain how to formulate the minicase 7 joint production problem. So this before you try to attempt this example, please do carefully read the text. Make sure you understand all the information given. So first, this problem is asking you to decide the production plan in order to actually achieve the largest possible profit. Then you know the profit actually is based on the time spent on each process. So here, basically, the decision should be how many hours you allocated in the process 1, for example, we use x1, and the process 2 for x2 in order to produce and use the resources to produce the products. So here, therefore, we just directly start the first step. We define decision variable. So we let xg be the time for process g. So here g equals to 1 or 2. And then second step, so all your input and output constraints are also given. Here you can see in the paragraph here, you can actually try to identify the constraints. So we know the resource are limited. So you have 300 units of petroleum and 400 units of gasoline. And then you also have the minimum production requirement, at least 600 units of fire starter and 225 units of lighter gas. So that's basically our constraints. And then we also know the time will actually directly related to your profit. So in this example, you can also identify the contribution margin for the two processes. Then the next question is how do you understand the table 4? So in the second paragraph here, we try to explain what's the meaning of table 4. So we just briefly look into this table based on the decision variable. So let's see if you use the time of process 1 to produce the fire starter fluid, you need to actually use petroleum or gasoline, and then per hour you could actually produce 15 units fire starter, 6 lighter gas by using 3 units of petroleum and 9 units of gasoline. This actually doesn't matter if they connected or not connected. Here we can, based on the decision variables, to formulate this problem. First, we try to write down the objective function. Just use a short writing. So the objective function only related to the time and contribution margin. So here we just write down for the process 1, the contribution margin or the unit profit is 150 krona for x1 hours plus 390 krona for x2 units. And this problem is a maximization problem, so we use maximize. So this is objective function. So next step, we try to formulate the constraints. So it's a little bit more complicated. So basically we have 2 types of constraints. One is a resource constraint. So as we said, the resource is limited. So you know the time and the petroleum and the gas will be consumed to produce the product. So here we start by looking at the first part of table 4 about the input. So that's basically the resource. So you have 3 units of petroleum. So we first focus on the petroleum petroleum consumption rate. So then we have 3 units per hour times the time you allocated to process 1 plus 12x2. So that's a total consumption for the petroleum resources given the time you allocated to each process. And then you have a limit, so you cannot use more than what you have, so less than or equals to 300 units. For gasoline, you have n x1 plus 6x2, then less than or equals to 450 units. Now we change the color for the second type of constraint, which are the output requirements. So here we look into the second part of table 4. Then if we only focus on the fire starter, now you know your output from 2 processes will be is right green. So 15x1 plus 9x2 should be greater than or equals to 600 units. And then for the lighter gas, you should have 6x1 plus 24x2 greater than or equals to 225 units. So that's a constraint. Do not forget, in the end, you should always add non-negativity constraints. In this example, I think the challenge will be how you define the decision variables. Once you actually understand this problem is actually the equipment allocation or resource allocation problem. So you have manufacturing process, then you have to decide how many hours you allocated to your machine or equipment so that you can get the required output. So then that's you will be able to formulate and solve this problem. So after I define decision variable, then you probably can better understand the constraints and the objective function. About how to solve this problem, you will get Excel documents and try to look into it.